let's learn about data types in Java. So basically what data type mean? It is just an attribute of data which tells compiler how the programmer intends to use the data. For example, if you're using a name called Ram, you need to inform Java that what type of data is it to process. So compiler should know that. So if we inform it is a string, then compiler would take that name as a string. So basically today we'll learn what are the different types of data types in Java. So for the data types, we do have two main category. One is primitive and second is non-primitive. Primitive helps to store simple data values, whereas non-primitive helps to store complex objects. So basically for primitive, we can categorize into two main category, numeric and non-numeric. So for the numeric, we can broadly categorize into two categories. So one is the integer numbers, which don't have any decimal point, and another one is floating point, which is the like whole number, right? We have the decimal point numbers. So for integer, we do have byte, short, int, long, whereas for floating point, we do have double and float. So similarly for non-numeric, we do have two types. We do have one as a character, which stores a single character like A or B, C, something like that. And with regards to the boolean, it holds either true or false. So let's go ahead and go to the non-primitive, which is a reference type as well. So for non-primitive type, we do have class, array, interface, object, and string. And with regards to the main difference, like this non-primitive type will have a method that it can use, versus like primitive type don't have a method in it. As I said earlier, primitive data types are helps to store simple values and it has no additional method. Let's learn in detail. So with regards to the data type, we do have byte, which stores 1 byte and it stores from the number -128 to 127. If you add it to 128, this byte won't support. It is like a container, right? It is a very small container with a size, memory size of 1 byte. So it can capture till 127 only. So if we wanted to store more than this value, we just have to move ahead to sort. So sort is little bigger container than byte. So sort is 2 byte in memory in size, and it stores from -32,768 to 32,767. So if we wanted to go ahead and store 32,768, this sort also won't be able. And in that case, we have to move it to int. So int, as you can see here, from the memory size itself is 4 byte, and it can store from somewhere from -2 billion to +2 billion. So it's a huge number, right? And int will be the maximum used data type as well for the number, for the whole numbers. So similarly, long, and for the long, it is 8 bytes. It is bigger than int as well, and it can store this many big values. So as you can see here, the bigger one for the storing the whole number is long. So let me hold over here and show you this in action. So let's say I would like to go ahead and create a byte here. And let's say I'll just say number 1 is byte, right, as a variable name, and I will just say I will just store 127 and I'll let me go.
Similarly, let me go ahead and create sort here. Let me say the variable name as number 2. Let me give a value as 32767, which is the maximum value here that can be stored. Similarly, let me go ahead and create int as well. Int number 3. Let me give any random number, as you can store till billion. So similarly, let me go ahead and create long. So long as number 4. So to declare a long number, you just have to mention the number L at the end. You can give capital L or small l, anything, that doesn't matter. But as you can see here, so this is how you declare. But I would recommend to give capital L, since the small l will look like 1. So here you go. Now it looks like a long number. So this is how you create a whole number, right? Integer numbers as a variable in Java. So why do we need to learn about this size? So what exactly you need to understand here is, let's say if I would like to store number 128, then in that case, the size of this byte is not able. As you can see here, if I go ahead and hover it, it says type mismatch cannot convert from int to byte, meaning that this number is huge, by default it is going to int, and it is not this container is not able to hold this number. But if you go below that, like 126, it's okay, right? Similarly, that's the same case with sort as well. So if the number can't be hold, it will give an error. As you can see here, the maximum that it can hold was 32767, right, in the positive side. Since I gave 768, it is giving a error. So we'll learn about typecasting, how can we manage that. But in the meantime, you can just understand that the size was not able, this container of the sort was not able to hold more than 32767. You don't have to, again, you don't have to remember like how much it holds, but you just have to understand the concept in Java. And similarly, the int is bigger than sort and long is bigger than the int.
Let's learn about memory allocation for the primitive variable in Java. So here I'm going to create a variable a with a value 1. And let's say I do have another variable with b which is equals to a. If I go ahead and print variable b here, let's see what comes, right? So as of now, if I print b, it comes 1. But let's say I increase the value of a to 5. So now let's see what happens, right? So let's run the code. As you can see here, the v value still remains the 1. Even though a is 5, so let me show you, the value of a is 5 already. So as you can see here, the value of a is 5, whereas the value of b was 1. So let me show you why. Here, while I declare the two variables a and b, let's say variable a and variable b, what the Java does is Java will create those two variables into memory location, right? So in two locations we have two variables, and the value is a is 1 and the b will be 1 as well, right? This is how Java has created. So they are independent of each other, meaning that a in a location of a it is referring 1, in a location of b it is referring 1. So if I go ahead and change it to 5 here, Java won't recognize, since it's totally independent of each other. The value of variable b will remain the same. This is how memory allocation works for the primitive type in Java.